Hello, in this lecture we'll answer two questions. On both questions we'll find out the area of a trapezoid. So we'll start with the first question. In the drawing we have trapezoid ABCD. Side AB of this trapezoid is equals to 2 units. Side DC equals to side CB. Those two angles are right angles. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is a trapezoid ABCD that is a quadrilateral because it has 4 sides, and because of the fact that this quadrilateral has 2 parallel sides, that is to say side AB is parallel to the opposite side DC. This trapezoid and this quadrilateral is defined as a trapezoid. So a trapezoid is a quadrilateral with one pair of parallel sides. So what is the area of this trapezoid ABCD? The area of any trapezoid is equals to the sum of its 2 parallel bases. It's actually AB plus DC, but we define side AB as A and side DC as A and side AB as B. So the sum of its 2 parallel bases is A plus B times the height that is edge over 2. The height edge must create 90 degrees with the 2 parallel bases. So the area of trapezoid ABCD equals to the sum of its 2 parallel bases, that is actually A plus B times the height edge over 2. Okay. And we also know that the perimeter of this trapezoid ABCD is equal to 16 units. That is to say, the sum of the lengths of its all sides is equal to 16 units according to what is given as a question. So we define the length of side AD as A, and we define the length of this side DC as B. And because of the fact that according to what is given as the question, DC equals to BC, and BC is B, therefore, and DC is B according to our definition, therefore BC must be also equal to B units in its length. We know that the perimeter of this trapezoid ABCD is equal to 16. That is to say, the sum of all its sides, the sum of the lengths of all its sides is equal to 16 units. That is to say, AB plus AD plus DC plus CB, in total it is equal to 16 units according to what is given as a question. So I'll write it down. AB plus AD plus DC plus CB, in total the sum of its all sides is equal to 16. AB plus AD plus DC plus CB equals to 16 units according to what is given as a question. That is to say, the perimeter of this trapezoid ABCD is equal to 16. AB is A, AB is 2, according to what is given as a question, plus AD is A according to our definition, plus DC is B, plus CB is also B. So in total 2 plus A plus B equals to 16, according to what is given as the equation. That is actually the perimeter of this trapezoid ABCD. So it is 2 plus A plus B is 2B equals to 16. Here we subtract 2 from this equation, and we get that A plus 2B equals to 16 minus 2 is 14. A plus 2B equals to 14. Here we subtract 2B from this equation, and we get that A equals to 14 minus 2B equals to 14 minus 2B. So actually, this is side AD equals to A, units in its length, and just write down found out that A equals to 14 minus 2B. Okay. In the next step, we will do a construction. That is to say, from the vertex B of this trapezoid ABCD, we will draw perpendicular on DC. Again, from the vertex B, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC. This point is point M. By doing this construction, we get the quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth pieces angle, in total it must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth pieces angle must be equal to 90 degrees in its size. So inside the quadrilateral ABMD, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral ABMD is a rectangle because it has 4 right angles. So this is quadrilateral ABDM, that is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABMD, side AD equals to the opposite side BM. But AD equals to 8, that is 14 minus 2B. Therefore, the opposite side BM must be also equal to 8, that is 14 minus 2B. Likewise, according to the same rule, in the same rectangle ABMD, side AB must be equal to the opposite side DM, but AB is 2, therefore the opposite side DM must be also equal to 2 units in its length. What is the length of this? This is line segment MC or side MC. MC equals to DC minus DM. Again, MC equals to DC minus DM. So write it down. Let me see, side MC equals to DC minus DM. So MC equals to DC. DC is B according to our definition, minus DM. We just write down found out that DM equals to 2. So in total, MC equals to B minus 2 units in its length. Let me see, side MC is B minus 2. So in the next step, I'll copy this right triangle BMC in a new page, and we will implement the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the opposite equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle BMC that I copied from the original drawing. This triangle BMC, according to the Pythagoras theorem, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. So I write it down. BC squared is equal to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, I shall find out that B squared equals to 14 minus 2B squared plus B minus 2 squared. So here we will open the brackets on this side of the this equation and get that B squared equals to 14 minus 2B squared. 14 minus 2B squared is 14 squared, that is 196. Plus 2B squared. 2B squared is 4B squared minus 2 times 14 times 2B, that is minus 56B, plus B minus 2 squared. B minus 2 squared equals to B squared plus 2 squared, that is 4, minus 2 times B times 2, that is minus 4B. So here we have B squared on both sides of this equation. So B squared will get cancelled. After we cancel B squared, on this side of the equation we left with nothing, that is to say 0. While on the other side of this equation we have 196 plus 4 is 200. And minus 56B minus 4B is minus 60B. And we have here plus 4B squared. So in total, we have found out that zero equals to 200 minus 60B plus 4B squared. Here we divide this equation by 4, and we will get that 4B squared over 4 is B squared. We have minus 60B over 4 is minus 15B. We have here 200 over 4 is 50, so it is plus 50 equals to 0 over 4 is 0. So in total, you should find out that B squared minus 15B plus 50 equals to 0. So actually this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This is the general formula. A, B, and C are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now, specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0. The variable that we are looking for is of course b, so x equals to b. The coefficient a equals to 1, the coefficient b equals to minus 15, and the coefficient c equals to 50. So the only thing that is left to do is to put the data for our specific quadratic equation inside this general formula for x, and we find out the value of the values of b, because x equals to b. So x equals to b, therefore we substitute x by b, and we get that b equals to minus b. b is minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. b is minus 15, therefore b squared is minus 15 squared, that is 225. We have here minus 4 times a times c. Minus 4 times a is 1, so minus 4 times 1 is minus 4 times a is minus 4 times 1, that is minus 4 times c is 50, so minus 4 times 50 is minus 200. So in total, inside the brackets, we have 224 minus 200 divided by 2a. a is 1, so 2a is 2 times 1, that is 2. So in total, if we found out that b equals to 15 plus minus, inside the root we have 225 minus 225 minus 200 is 25, and the square root of 25 is 5 divided by 2. So b equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for b. We define the first solution as b1 and the second solution as b2. The first solution for b is b1, that is equal to b1 equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b is b1 equals to 10, and we have also a second solution for b, that is b2. According to the second solution for b, b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2 equals to 5. So we know that AD equals to A and A equals to 14 minus 2B. So I write it down. AD equals to A, and we found out that AD equals to 14 minus 2B. So 14 minus 2B is the length of side AD. And therefore, this expression is a length, it must be a positive number. This is to say, 14 minus 2B must be greater than 0. 14 minus 2B is a length, must be greater than 0. So here we add 2B to this inequality, and we get that 14 is greater than 2B. Here we divide this inequality by 2, and finally we get that 2B over 2 is B, so B is smaller than 14 over 2 is 7. So B must be smaller than 7. The first solution for B is B1, that is equal to 10. 10 is greater than 7, and B must be less than 7, so this solution is the correct solution. We cancel the solution, and then we have to only with the second solution for B, that is B2, that equals to 5. Or we can write down that B equals to 5, because that is the only solution for B. Okay. Our mission is to find out the area of this trapezoid ABCD. So the area of trapezoid ABCD according to the formula that I present to you in the beginning of the lecture. The area of this trapezoid ABCD must be equal to the sum of its two parallel bases. It is actually AB plus DC times the height over 2. The height must create 90 degrees with the two parallel bases, and AD definitely creates 90 degrees with those two parallel bases. Therefore, AD is the height divided by 2. So in total, we should find out that the area of this trapezoid ABCD equals to AB plus DC times the height AD over 2. AB is 2, so we substitute AB by 2 plus DC. DC, in total it is DM plus MC. DM is 2 plus MC. MC is B minus 2, but B is 5. So B minus 2 is 5 minus 2, that is 3. So in total, DC equals to 2 plus 3, that is 5. So substitute DC by 5 times the height AD. The height AD equals to A, and A equals to 14 minus 2B. B is 5, so 2 times 5, that is 10. Therefore, AD in total equals to 14 minus 10, that is 4. The height A is 4. The height AD is 4. So substitute AD by 4 divided by 2. So the area of trapezoid ABCD equals to 2 plus 5, that is 7. And we have here 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14 square units. So we should find out that the area of trapezoid ABCD is equal to 14 square units. So repeat again, I shall find out that the area of this trapezoid ABCD, that is the area that we are looking for in this question, is equal to 14 square units. So we finish with the first question. In the next step, I present to you the second question, and we solve the second question of this lecture. In the second question, we have to find out the area of another trapezoid. So the mentioned in the beginning of the lecture. So in the drawing we have trapezoid ABCD, and our mission is to find out the area of this trapezoid ABCD. It is given us the question that AD equals to 2x, side BC equals to x. This is line segment AM, that is equals to 3 units in its length. This is line segment BM, that is equals to 2 units. Those two angles are right angles, both right angles, and this is also a right angle. That is to say, angle AMB is equal to 90 degrees in its size. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, we define this angle. This is actually angle BMC as alpha. So in the right small triangle ABC, in the right small triangle MBC, this angle equals to alpha. This angle equals to 90 degrees. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Here, this is side DC of trapezoid ABCD. So DC is the side of a trapezoid it is absolutely a straight line. So if we focus on the upper side of this straight line, this 8 point M, here the sum of the angles must be equal to 180 degrees according to rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. In this case, it will be, we implement rule 3 by saying that the sum of the angles on the upper side of the straight line DC at point M must be equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, this is the right angle, plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of DC at point M according to rule 3. So in the right triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. It is very easy to see that those two right angles are similar to each other according to angle similarity rule. Why? Both triangles have angle alpha, both triangles have the right angle, and both triangles have this angle that is 90 degrees minus alpha. Therefore, those two triangles, that is to say, triangle ADM is similar to this triangle BCM according to angle similarity rule. So I write it down. The big right triangle ADM is similar, this is the sign of similar, to the small triangle, the small right triangle BCM according to angle similarity rule. And for the fact that those two right triangles are similar to each other, the following relationship exists between their sides. Side AD of this right triangle ADM over side MC of this one right triangle MCB is equal to side DM of this right big triangle ADM over side BC of this right small triangle BCM. Repeat again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. Side AD of the right triangle ADM over side MC of the right small triangle BCM is equal to side DM of the right big triangle ADM over side BC of the right small triangle BCM. And also side AM of the right big triangle ADM over side BM of the right small triangle BCM. So this equals to side AM of the right big triangle ADM over side BM of the right small triangle BCM. AD is 2x over MC. MC is the missing side, so we will leave it as it is. and it is equals to dm. dm is also the missing side, so we leave it as it is, over bc. bc is x. And it is also equals to am. am is 3 according to what is given us in the question, over bm. bm is 2 according to what is given us in the question. So in total, we actually found out that two x over mc equals to dm over x equals to 3/2. So those two expressions are equal to each other. Therefore, you get equation 1 from those two expressions that are equal to each other. That is to say, according to equation 1, 2x over mc equals to dm over x. So I write it down. According to equation 1, two x over mc equals to dm over x. Actually, we take another equation, those two expressions are equal to each other. Therefore, we get equation 1 from those two expressions that are equal to each other. Okay. So, according to the equation 1, 2x over mc equals to 3/3, to 3/2. Because we have to find out the value of x, so we have to compare something that is missing to a number. Otherwise, if we have too much variables, we will not be able to find the value of x. So here we have 2x over mc equals to 3/2. This will be equation 1. 2x over mc equals to 3/2. So here we will multiply this equation by mc, and you get that 2x equals to 3/2 times mc. Here we multiply this equation by 2, and then we divide it by 3 simultaneously, and you get that mc, according to equation 1, mc in total equals to 2 times 2x over 3. So mc in total equals to 2 times 2x is 4x over 3. So if I found out that mc equals to 4x over 3 units in its length. This is side mc, this is equals to 4x over 3 units. We continue to focus on this long equation. Those two expressions are also equal to each other, therefore we get equation 2 from those two expressions that are equal to each other. So according to equation 2, we get that dm over x equals to 3/2. dm over x equals to 3/2. So here we multiply this equation by x, and finally we get that dm equals to 3/2 times x. 3x over 2. So if we found out that actually we found out that MC equals to 4x over 3. MC equals to 4x over 3. And we just like to found out that dm equals to 3x over 2. dm equals to 3x over 2. 3x over 2 units in its length. So in total, if you found out that dm equals to 3x over 2 and mc equals to 4x over 3. Okay, so in the next step, we will implement the Pythagoras theorem on this right small triangle BMC. So I'll copy this right small triangle in a new page and we will implement the Pythagoras theorem on this right small triangle. The hypotenuse BM equals to 2 units in its length, BC equals to x, and we just found out that MC equals to 4x over 3 units in its length. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right small triangle BMC that according to the original drawing, according to the Pythagoras theorem, in this right triangle BMC, BM squared, that is the square of the hypotenuse, equals to BC squared plus CM squared. So I write it down. So BM squared, that is the square of the hypotenuse, is equal to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4, and it is equal to BC squared. BC is x, therefore BC squared is x squared plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. Four x over 3 squared is 4 squared, that is 16, over 3 squared, that is 9. So in total, 4x over 3 squared is 16x squared over 9. So here we will multiply x squared by 9 and then we will divide it by 9 in order to a common factor with this expression, and we get that 4 equals to 9x squared over 9 plus 16x squared over 9. 9 over square plus 16x squared is 25x squared over 9. So in total, we found out that 4 equals to 25x squared over 9. Here we will multiply this equation by 9 and we get that 25x squared equals to 9 times 4, that is 36. So here we will divide this equation by 25 and we get that x squared equals to 36 over 25. So here we take a root out of this equation and finally get that x equals to the square root of 36 is 6 over square root of 25 is 5. So in total, we should find out that x equals to 6 fifths. If x equals to 6 fifths, here BC is equals to x is equal to 6 fifths. So our mission is to find out the area of this trapezoid ABCD. So what is the area of this trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, the area of this trapezoid ABCD must be equal to the sum of its two parallel bases times the height over 2. The two parallel bases are AD and BC, and the sum of those two parallel bases is of course AD plus BC times the height. The height must create 90 degrees. The two parallel bases. DC indeed makes 90 degrees with the base BC, and DC also makes 90 degrees with the base AD. Therefore, the height of trapezoid ABCD is DC divided by 2. So in total, if we found out that the area of this trapezoid ABCD is equal to AD plus BC, that is the sum of the two parallel bases times the height DC over 2. AD is 2x plus BC. BC is x times the height DC. DC in total is 3x over 2 plus 4x over 3 divided by 2. So in total, if we found out that the area of this trapezoid ABCD, that is the area that we are looking for this question, is equal to 2x plus x times 3x over 2 plus 4x over 3 divided by 2. 2x plus x is 3x. So 3x, and inside the brackets we have 3x over 2 plus 4x over 3. So here we take a common factor of 6 out of those two expressions. That is to say, we multiply the numerator of this expression by 3, and then we multiply also the denominator of this expression by 3. So 3x times 3 is 9x over 2 times 3 is 6. Likewise, we will multiply the numerator of this expression by 2, and then we will multiply the denominator of this expression by 2. So 4x times 2 is 8x, that is plus 8x, and 3 times 2 is 6. So to that, we should find out that 9x over 6 plus 8x over 6 plus 3x is the area of trapezoid ABCD. So it is 3x times 9x plus 8x is 17x divided by 6, and we have to divide it also by 2. Here we took 6 as a common factor out of this expression, but I didn't divide this expression by 2. We have to divide all by 2. So it is divided by 2. Also here we have divided by 2. Okay. So we have here 6 in the denominator and 3 in the numerator. So we divide both the numerator and the denominator of this expression by 3. 3 over 3 is 1, so or 3x over 3 is x. So in total in the numerator we left with x times 17x. In the denominator we have 2 times 6, so 6 over 3 is 2. So in total in the denominator we have 2 times 2. In the numerator we have 17x times x is of course 17x squared. We can leave it as it is 17x times x over 2 times 2 is 4. We have already found out that x equals to 6/5. So we just substitute x by 6/5 and that will be the answer for this. We'll find out the trapezoid ABCD. So in total it will be equal to 17 over 4 times x. X is 6/5 and we have x again, so it is again 6/5. So in total the trapezoid ABCD equals to this expression. So we have here 6 times 6 is 36 and 36 over 4 is 9. So we cancel those three numbers and instead of them we write down 9 plus 36 over 4 is 9, so it is 9 times 17 over 5 times 5, that is 25. So in total we should find out that the area of trapezoid ABCD equals to 9 times 17, that is 153 over 25. Repeat again, the area of this trapezoid ABCD is equals to either 153 over 25 units, or in terms of numbers it is equal to 6.12 square units. That is the answer to the second question. So repeat again, if you found out that the area of this trapezoid ABCD it is equal to either 153 over 25 square units, or in terms of numbers the area of this trapezoid ABCD is equal to 6.12 square units. So we finish with the second question. In the next step, some other lecture, we start with the first question, of course. In the first question, our mission is to find out the area of this trapezoid ABCD. Repeat again, a trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD. It is a quadrilateral because it has 4 sides, and because of the fact that in quadrilateral ABCD, side AB is parallel to the opposite side DC, this quadrilateral with one pair of parallel sides is defined as a trapezoid. So ABCD is a trapezoid because of the fact that side AB is parallel to the opposite side DC. So those two parallel sides, that is to say AB and CD, are defined as the bases of this trapezoid. And the area of this trapezoid ABCD is equal to the sum of its two parallel bases. AB is A and DC is A and AB is B. So the sum of its two parallel bases is A plus B times the height, that is h over 2. Repeat again, the area of any trapezoid equals to the sum of its two parallel bases times the height over 2. In this case, the two parallel bases are A and B, therefore the sum of its two parallel bases is A plus B times the height h over 2. The height h must create 90 degrees with the two parallel bases. You can see that the height h creates 90 degrees with the base DC, and the height h also creates 90 degrees with the other base AB, this base AB. So in total, if you found out that the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually A plus B times the height h over 2. Okay. So in the drawing, we have trapezoid ABCD. We know that side AB equals to 2 units in its length. Those two angles are right angles. And we also know that side BC equals to side DC. We know that the perimeter of this trapezoid ABCD is equal to 16 units. That is to say, what is the perimeter? The perimeter is the sum of the lengths, the sum of all the lengths of this, the sum of the lengths of this trapezoid ABCD. And the sum of the lengths of all the sides of trapezoid ABCD. That is to say, it is AB plus AD plus DC plus CB. So that sum is equals to 16. And again, the sum of the lengths of all the sides of this trapezoid ABCD is equal to 16 units according to what is given in the question. So, according to what is given in the question, AB plus AD plus DC plus CB, that is the sum of all the sides of trapezoid ABCD, is equal to 16. AB is 2. AD is A according to our definition. After we define AD as A, we define DC as B, and because of the fact that DC equals to CB and DC is B, therefore CB must be also equal to B. So in total, the area, the perimeter of trapezoid ABCD is equal to AB, that is 2, plus AD, that is A, plus DC, that is B according to our definition, and CB is also B because DC equals to CB. So in total, the perimeter of this trapezoid ABCD is A, 2 plus A plus B plus B, that is 16 according to what is given as the question. So it is 2 plus A and B plus B is 2B, that equals to 16. Here we subtracted 2 from this equation. Finally found out that A plus 2B equals to 16 plus 2 is 14. Here we subtracted 2B from this equation, and finally found out that A equals to 14 plus 2B. So if we found out that AD is equals to A is equals to 14 plus 2B. In the next step, we did a construction. That is to say, from the vertex B of trapezoid ABCD, we draw perpendicular on DC. Again, from the vertex B, we draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the tangent point of the perpendicular from point B and DC. This point is point M. By doing this construction, we can do the quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. Those two angles are right angles according to what is given as the question, and this angle is a right angle according to our construction. So, in total, inside the quadrilateral ABMD, we have 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 450 angle, in total it must be equal to 360 degrees. According to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 450 angle must be equal to 90 degrees in its size. So inside quadrilateral ABMD, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be its rectangle, not a square. So we relate to this quadrilateral ABMD is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle ABMD, side AB must be equal to the opposite side DM. But AB is 2, according to what is given as a question. Therefore, the opposite side DM must be also equal to 2 units in its length. Likewise, according to the sum rule, in the sum rectangle ABMD, side AD must be equal to the opposite side BM. But AD is 8, that is 14 rounds 2B. Therefore, the opposite side BM must be also equal to 8, that is 14 rounds 2B. Okay. So, what is the length of this missing line segment? MC. MC equals to DC minus DM. MC equals to DC minus DM. So, MC equals to DC is B according to our definition, and we just right now found out that DM equals to 2. So in total, MC equals to B minus 2. In the next step, I copied this right triangle, again BMC in the new page, and we implemented the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, This is the right triangle BMC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. BC is B, therefore BC squared is B squared plus BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, we should find out that B squared equals to 14 minus 2B squared plus B minus A squared. Here we open the brackets on this side of this equation and finally found out that B squared equals to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared. 2B squared is 4B squared, minus 2 times 14, that is minus 28 times 2B. 28 minus 28 times 2b is minus 56b, and we also here plus b minus 2 squared. B minus 2 squared equals to b squared plus 2 squared, that is 4, minus 2 times b times 2, that is minus 4b. So here we have b squared on both sides of this equation, so b squared will get cancelled. After cancelled b squared, in this side of the on this equation we left with nothing, that is to say 0, while on the other side of this equation, here we have 196 plus 4 is 200, and we have also minus 56b minus 4b is minus 60b, and we have also 4b squared. So in total, if we found out that zero equals to 200, equals to 200 minus 60b plus 4b squared. Here we divided this equation by 4 and finally found out that 4b squared over 4 is b squared, minus 60b over 4 is minus 15b, and 200 over 4 is 50. 0 over 4 is 0. So in total, we found out that b squared minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is of course b, so x equals to b, the coefficient a equals to 1, the coefficient b equals to minus 15, and the coefficient c equals to 50. So the only thing that is left to do is to put this data for our specific quadratic equation in this general formula for x, and we find out the value or the values of b. Why? Because x equals to b. We did it, and we found out again x equals to b, so we substitute x by b, and it is equal to minus b. B is minus 15, so minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, so b squared is minus 15 squared, that is 225, minus 4 times a times c. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c, that is 50. So minus 4 times 50 is minus 200. So total inside the root, we left only with 225 minus 200. That's actually 25, and the square root of 25 is 5. So in total, we found out that b equals to 15 plus minus 5 over 2. So here we have two solutions for b. We define the first solution as b1, and the second solution for b is b2. According to the first solution, for b, the first solution is b1, that equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b, that is b1, is 10. While the second solution for b, that is b2, is 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, that equals to 5. We know that side AD is equals to a, and the left of side AD is 8, that is 14 minus 2b. So side AD of trapezoid ABCD, the left of side AD is a, according to our definition, We found out that A equals to 14 minus 2B. So AD is the length of 14, AD is equals to 14 minus 2B is the length of side AD of trapezoid ABCD. So AD is a length, it must be a positive number. That is to say, the expression 14 minus 2B, that is the length of side AD, must be a positive number. That is to say, it must be greater than 0. So the length of AD, that is 14 minus 2B, must be a positive number. That is to say, it must be greater than 0. We added 2B to this equation, to this inequality, and found out that 14 is greater than 2B. Here we divided this equation by 2, this inequality by 2, and found out that 14 over 2 is 7, and is greater than 2B over 2, that is B. So we found out that B must be less than 7. But according to the second solution, B1 is 10. B must be less than 7, and B equals to 10 is greater than 7. So this solution is the correct solution. And we will focus on the second solution for B, that B equals to 5. 5 is less than 7. So that is the only solution that is possible for B. B equals to 5 units in its length. Our mission is to find out the area of this trapezoid ABCD. According to the equation that I presented to you, the area of trapezoid, any trapezoid equals to the sum of its two parallel bases times the height over 2. The two parallel bases of this trapezoid ABCD are AB and DC. So the sum of the two parallel bases is AB plus DC, and the sum of the two parallel bases of trapezoid ABCD is AB plus DC times the height. The height is AD. Why the height is AD? Because of the fact that the height must create 90 degrees with the two parallel bases, and indeed side AD creates 90 degrees with those two parallel bases. So the height is AD over 2. So I shall find out that the area of trapezoid ABCD equals to AB plus DC times the height of AD over 2. AB is 2 according to what is given as the question, times DC. DC is 14 minus 2B. B is 5. 2B is 2 times 5, that is 10. So 14 minus 10 is 4. So AD equals to 4. So substitute AD by 4 divided by 2. 2 plus 5 is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14 square units. So she found out that the area of this trapezoid ABCD is equal to 14 square units. We finish with the first question. In the next step, I presented to you the second question, and you solve the second question of this lecture. Our mission in this second question is to find out the area of this trapezoid ABCD. So, in the drawing we have trapezoid ABCD. In addition, we know that this is side AD of trapezoid ABCD that is equals to 2x units in its length. Side BC equals to x units in its length. This is line 7 AM, that is equals to 3 units in its length. This is line 7 BM, that is equals to 2 units in its length. This is angle A and B, that is a right angle. Those two angles are also right angles. Again, our mission is to find out the area of this trapezoid ABCD. We defined this angle as alpha, that is to say angle BMC is equals to alpha according to our definition, or the size of this angle is alpha degrees. So in the right triangle BMC, this angle equals to alpha, this angle equals to 90 degrees according to what is given as the equation. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of DC at point M, here the sum of the angles must be equal to 180 degrees according to all three. That says that the sum of the angles on one side of a straight line is equal to 180 degrees. So the sum of the angles, what is one side, is on the upper side of DC at point M must be equal to 180 degrees. So each angle we have at the upper side of DC at point M, we have this angle that is alpha, plus this angle that is 90 degrees, plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to all three. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of DC at point M according to all three. Okay? So this missing angle must be equal to 90 degrees minus alpha. So in the right big triangle ADM, this angle equals to 90 degrees minus alpha. This angle equals to 90 degrees. Therefore, this first missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Okay? So we focus on those two triangles. This is the small triangle BCM, and this is the big triangle ADM. Those two angles, they are both equal to alpha, therefore they are equal to each other. Those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So if you found out that all the figures of the right big triangle ADM are correspondingly equal to all the figures of the right small triangle BCM. Therefore, those two right angles are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. So, repeat again, if you found out that the right big triangle ADM is similar, this is the sign of similar, to the right small triangle BCM according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AD of this right triangle ADM over side MC of this right small triangle BCM is equal to side DM of this right big triangle ADM over side BC of this right small triangle BCM. And also side AM of this right big triangle ADM over side BM of this small right triangle BCM. And again, we derive that AD over MC equals to DM over BC equals to AM over BM. AD is 2x over MC. MC is the missing side, so we limit as it is. And it is equals to, this is MC, so we limit as it is, because it is the missing side. And it is equals to DM. DM is also the missing side, so we limit as it is, over BC. BC is x, and it is equals to AM. AM is 3, over BC that is 2. So in total, we should found out that 2x over MC equals to DM over x equals to 3 halves. Those two expressions are equal to each other, so we get the equation 1 from those two expressions that are equal to each other. That is to say, according to equation 1, 2x over MC equals to 3 halves. Again, 2x over MC equals to 3 halves. Here we multiply this equation by MC, and finally found out that 2x equals to 3 halves times MC. Okay. Here we multiply this equation by 2, and then we divide it by 3 simultaneously, and finally found out that MC equals to 2/3 times 2x. 2 times 2x is 4x, so in total this expression equals to 4x over 3. So in total we should found out that MC equals to 4x over 3. This is side MC, that is equals to 4x over 3. We continue to focus on the long equation. This long equation. Those two expressions are also equal to each other, so we can have equation 2 from those two expressions that are equal to each other. That is to say, dm over x equals to 3 halves. And again, we get equation 2 from the long equation. According to equation 2, dm over x equals to 3 halves. Here we multiplied this equation by x and found out that dm equals to 3x over 2. So this is sine dm that equals to 3x over 2. In the next step, I copied this right small triangle BCM in a new page and we implemented the Pythagoras theorem on this right small triangle BCM. So actually, this is the right small triangle BCM that I copied from the original drawing. Here by PT derivation for Pythagoras theorem, according to the Pythagoras theorem, in this right small triangle BCM, BM squared, that is the square of the hypotenuse, equals to BC squared plus CM squared. BM is 2, therefore BM squared is 2 squared, that is 4. Again, BM squared equals to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4, and this equals to BC squared. BC is x, so therefore BC squared is x squared plus MC squared. MC is 4x over 3. MC squared is 4 squared, that is 16, times x squared over 3 squared, that is 9. So in total, 4x squared is 16x squared over 9. So 4x over 3 squared is 16x squared over 9. So in total, if we found out that 4 equals to x squared plus 16x squared over 9. Here we multiplied x squared by 9 and then we divided by 9 in order to have a common factor with this expression. So we have 9x squared over 9 plus 16x squared over 9. So 4 equals to 9x squared over 16x squared is 25x squared over 9. So in total, if we found out that 4 equals to 25x squared over 9. Here we multiply this equation by 9 and finally found out that 9 times 4 is 36 equals to 25x squared. So 25x squared equals to 36. Here we divided this equation by 25 and finally found out that x squared equals to 36 over 25. Here we took a root out of this equation and finally found out that x equals to the square root of 36 is 6 over the square root of 25 is 5. So in total, we found out that x equals to 6 fifths. So this natural BC is equals to x is equals to 6 fifths. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? According to the equation that the formula that I presented to you in the beginning of the lecture, the area of any trapezoid equals to the sum of its two parallel bases. This trapezoid ABCD, side AD is parallel to side BC. So this AD plus BC times the height, that is DC over 2. Why the height is DC? Because it creates 90 degrees with the two parallel bases, AD and BC. So in total, the area of this trapezoid ABCD equals to the sum of its two parallel bases, that is AD plus BC times the height DC over 2. And again, if we found out that the area of this trapezoid ABCD, that is the area that we are looking for this question, is equal to the sum of its two parallel bases, that is AD plus BC times the height DC over 2. AD is 2x plus BC is x. The height times the height DC. DC is 3x over 2 plus 4x over 3 in total. Again, AD is 2x, BC is x, and DC is 3x over 2 plus 4x over 3, divided by 2. 2x plus x is 3x. Here we took 6 as a common factor out of these two expressions. That is to say, actually multiply this expression by 2 and then we divide it by 2. Actually, we multiplied, in order to a common factor of 6, we multiplied this expression by 3 and then we divided it by 3. Because 2 times 3 is 6, so we have to multiply it by 3 in order to have a common factor of 6. So 3x times 3 is 9x, and 2 times 3 is 6. And we have to multiply this expression and then we divide it, to multiply it by 2 and then we divide it by 2 in order to a common factor of 6. So 4x times 2 is 8x, and 2 times 3 is 6. So in total, this expression equals to 9x plus 8x divided by 6. And we have to divide it by 2. Okay? So we have 3x. Inside the brackets we have 9x plus 8x, that is 17x. In the denominator we have 2 times 6. So we have x, we have here 3x over 6. So we divided both the numerator and the denominator of this expression by 3. 3x over 3 is x, so in total in the numerator we have x times 17x, while here we have 6 over 3 is 2. So it is, in total we left only with 2 times 2. 2 times 2. So we have in the numerator x times 17x, so 17 times x, and 2 times 2 is 4. We found out that x equals to 6/5, so we substitute x by 6/5. So it is 17 over 4. X is 6/5, and also another x we have here, so it is 6/5 again. So we have here 6 times 6 is 36, and 36 over 4 is 9. So instead of those three numbers, we wrote down 9, because 36 over 4 is 9. And we left also with here with 17, that is 9 times 17, and in the denominator we have 5 times 5, that is 25. So in total, there of this trapezoid ABCD is equal to, this trapezoid ABCD is equal to 9 times 17 is 153 over 25. So the area of this trapezoid ABCD is equal to either 153 over 25 square units, so in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. Okay, thank you very much.